This board came to me after another service. It's a budget board, MSI B550M Bazooka. Nothing special on paper and not particularly remarkable by any measure, but for the customer it had some value, and that's why, regardless of whether the repair made financial sense, it ended up on my bench for diagnostics. I wouldn't have made a video about this one. At first it looked like a routine case, just another board that needed to be looked at, but as the diagnostics moved forward it became clear that this case was not quite ordinary, and I think it's worth sharing with you. So stay until the end of this video, it's going to be interesting. Alright, MSI B550M Bazooka, budget board, B550 chipset, aim for socket, nothing exotic, but the history on this one is a little more interesting than usual. Customer says it stopped posting, CPU debug LED is on solid, no reaction, no picture, standard dead board story, except it's already been in another repair shop before it came here, so they try to refresh the BIOS, something went wrong during the process and they burned the PCI Express slot, so not catastrophic, but it's there. That tells us two things right away. Someone was already inside this board, and we can't take anything for granted about the current state of it. So we have two problems to think about. One is, why is this board not posting? Two, is the PCI Express damage connected to that, or is just a cosmetic collateral from whatever happened over there? So we're going to go through this the same way we always do. Resistance checks first, then power on, and see what we actually have. Visual inspection under the microscope, then we follow the signal. No guessing, let's get started. Okay, let's check the resistances on the main power rails, and we will use, as usual, ATX 24 pin header on the motherboard for that. You will see the multimeter on the top right side of the screen, and left pin to the ground, and so 3.3 volts, the pin number 1, and we have around 1 kilo ohm, 950 ohms, 5 volts, we have 157 ohms. I guess this is a way low, but who knows? 5 volts standby, 758 ohms, 12 volts, and here we have kilo ohms here, so minus 12, just check for no short, it's usually mega ohms and increasing. Also we have 12 volt CPU, and we have kilo ohms here, and the 12 volts to the core. This one, mega ohms, V-core itself is kilo ohms as well, and 12 volts to SOC, mega ohms, SOC itself, kilo ohms, so no short. Then I see a couple of coils visible here, so we just can put this probe to ground. This is probably 5 volts coil. Okay, it's kilo ohms here. This is maybe memory coil 2.4 volts, and it's have kilo ohms. Here we have another one, kilo ohms. This is more of a CPU, probably 1.8 volts, and we have kilo ohms here. What else? We have coil here, kilo ohms, and I guess that's it. So let's try to power it up and to see what happens. So for the CPU, we're going to use the Ryzen 3 Pro 4350G. It's an AM4 CPU. $244 milliamps right away. This is way too much, I guess. So we'll press the power button, and we have a reaction, actually. Here you see the CPU debug LED, it's on. At this stage, the board behaved exactly as the customer described in the notes that came with it. I measured voltages on all visible coils, everything was within normal range. So there was nothing left to do but deal with the BIOS chip, the one that was already worked on at the previous service so aggressively that they managed to burn the PCI Express slot plastic in the process. The decision was straightforward: remove the chip, refresh it with the known good original firmware downloaded from the MSI website, and solder it back onto the board. Okay, so let's see under the microscope. What do we have here? Where is the BIOS is? Here is the BIOS chip, so it was definitely desoldered. So, and this is the damage made to the PCI Express slot, so you can see it clearly. There's a melted plastic inside. So I'm not sure even if this space will be enough to put in the graphic card. I guess we have another problem with the BIOS because what I see here is probably a knocked off components. So let me check a board view real quick for that, and I will come back to you. All right, so according to the board view, we have a real problem which could potentially prevent the board from starting. I guess it's not even potentially, it's 100% that that's a problem, and the board will not start without this resistor. So right here, we should have a small resistor. This resistor is actually responsible for deasserting SPI hold signal for the SPI flash chip, and the flash chip literally all the time is on hold, and so I guess it cannot be read anyway, and so this is definitely prevented the motherboard from the booting. And also there is a capacitor right here. It's a 1 micro no, it's a 100 nanofarads capacitor in 402 package, and the resistor is also in package 402. It's a 10K resistor, and without them, there'll be no BIOS actually. So what should we do? I guess we should desolder the BIOS, flash a correct version because I don't know what is inside there, and to solder back this resistor and the capacitor over here. Let's start with the BIOS chip, and we will see if we have any progress on this repair. We will write and verify. So let's do it. Yes. Okay, we have a verification error again. Whoa, what happens here? What the hell? Does it mean that the chip is dead? It's unbelievable. It looks like this is a 3-volt chip. It's not 1.8 volts. This is W25Q256JV. And if we're looking at the board view, so the pin number 8 is definitely 1.8 volts. This chip is wrong. It's a 3-volt chip. and the motherboard board view shows exactly 1.8 volts. So I guess we need to check with the motherboard. Oh, it is actually powered without the CPU, which is quite handy. And the pin number 8, and we have a 1.8 volts here. So the BIOS chip we have is a wrong one, and on the previous repair shop or whoever tried to repair it choose the wrong one. If you're not familiar with BIOS flash chips, here's a quick note. These chips differ by capacity, interface protocol, package, and functionality. But the most critical parameter, and I want to emphasize this, is operating voltage. Modern motherboards use either 3.3 volts or 1.8 volts chips. Put the wrong one in and it simply won't work, or worse, a 1.8 volt chip supplied with 3 volts will most likely not survive. I have no good explanation for how a 3.3 volt chip ended up on a board designed for 1.8 volts, but that's what we're dealing with. Okay, so I found the same chip what we need on the donor board, and it looks like that we need MX25U 2567 3G, and this is a B550 Tomahawk Max Wi-Fi, so they use the same 1.8 volts chips. And I guess that we can desolder it from here and program and solder it to our patient. And let's see. Okay, let's try to power it on. One more thing, since we replaced the BIOS chip, we need to reset CMOS, and this is probably the headers for that. Let me check with the board view real quick. It's a case open. No. So there's no clear RDC, right? Okay. So what we can do, we just can remove the battery. By the way, let's measure the battery. If we have any voltage in this, let's say voltage. And we have actually 3 volts, so the battery is good. However, we should short the battery. Now we can plug in, power button, and with the power. The power screen will be here. Okay, this will be positioned right here. Power on. CPU. Okay. VGA. We'll have a power screen. And yes, we do. So that was the problem. Unbelievable. Okay, what's the BIOS we have? Let's see. That should be the latest BIOS we have flashed there. And it is. It's 2025, and it's a September 8th of the September. Perfect. Nice. So DDR voltage, normal, V4 voltage, normal. Everything is okay and working as expected, I guess. Of course, we will check everything, but I guess we have a successful repair here. Budget board, complicated history, wrong chip, wrong voltage, burned slot plastic, but it posts now. Sometimes the most straightforward fix is just undoing what someone else got wrong. Hope you enjoyed this one. Like and subscribe if you did. It really helped the channel. See you in the next video.